exactly in the order of the textbook. We're going to do the Venn diagrams and we're going to finish it. And then we will do the 3 diagrams. Now what we're going to do today is actually only revision of grade 10 work. It's things that you should already know, but as I say, because we only use it at probability, I think most of you might have forgotten it. Okay. Then we're also going to look at a little bit of the probability language. You guys must remember that English language and math language not necessarily the same, eh? Okay. So it's going to be a lot of definitions and things now, so don't get worked up or feel like it's very difficult. We're going to work with it a lot and then you'll get to know it. So the first thing we're going to look at is inclusive events. Okay, so I want you to write down that formula. This formula reads as follows. The probability of getting A or B is equal to the probability of getting A plus the probability of getting B minus the probability of getting A and B. Alright, now normally when we explain probability, it's a bit weird when we're talking about A and B. So I want to explain it to you in a way that you can relate to it. But with the English class, you guys must don't have tourism, né? So that makes it difficult for me because tourism is the perfect subject that we can want to explain. So I'm going to have us pretend. Okay. We're going to compare learners that have geography and learners that have tourism. Okay, so you now have to pretend you have tourism. So in this class, you don't have to draw this following one. This is just for you to understand. Okay. If we draw a Venn diagram with inclusive events, I'm going to have tourism. Now let's start with geography. And I'm going to have tourism. Alright, now who of you in this class do have geography? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 of you have geography. Now let's pretend you could have had tourism. Who of you would have chosen to take tourism? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Who of you that put up your hands now has geography and you also put your hands up for tourism? Put up. 1, 2, 3, 4, 5, 6, 7. How many of you or who of you don't have tourism or geography? Neither of them. And you don't pretend to have tourism as well, no? Okay. And in this class, there's a total of 3, 6, 9, 11, 13, 16. We've got a total of 16 learners in this class. Right. Now, if I were to draw a Venn diagram for this situation, and I did it in the following way, look at what I'm doing. We can say that there are 10 learners that has geography. Okay? Goes in the geography circle. Then we have 11 learners that has tourism. Okay, so you understand what the B and the A stands for. Right. Now, these learners that have geography and tourism has to be in the middle. Okay. And the learners that have neither of the subjects has to be on the outside. Okay. But if you look at this now, remember this entire circle belongs to geography. Which means if I look at this Venn diagram, I'm saying there are 17 kids that has geography. And this entire circle, despite the cut, the entire circle belongs to tourism. So I'll be saying there are 18 learners that has tourism. Okay? Which brings us to a total of 28 plus 2, 32 learners, of which we only have 16 learners. So you can see the problem that we have here. So that's why when we draw a Venn diagram, when we draw a Venn diagram, we will always start in the middle. Okay, so we start with the 7. Those 7 learners, do they have geography? Yes, so they're in the geography circle. Do those 7 learners have tourism? Yes, so they're in the tourism circle as well. So, in a total, there must be 10 learners for geography. So therefore, there was only 3 of them that has geography only. But the 10 that make up the geography class, 7 of them also have tourism. And then what's the number I'm going to put in there? 4. Okay, so let's check. Oh, someone put their hands up too many times. Somewhere here. The none. Okay, let's just check who has geography. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, who has tourism? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I not count correctly there? Okay, we'll make it 10. Who of those hands that went up had geography and tourism? 1, 2, 3, 4, 5, 6, 7. Whose hand has not gone up at all? 1, 2, 3. Okay, don't worry, now it checks out. Now we've got the 16 learners we had there. Okay, so it was just someone's hand that went up when it shouldn't have. Okay, so if I check this now, 3 that has geography only. Okay, 7 that has geography and tourism. 3 that has tourism only. 3 that doesn't have geography or tourism. And when I add that 3 plus 3 plus 7 plus 3, it gives me the total of the class of 16. Okay, so do you understand the circle where there's only a number? And the part of the circle that is shared by both of them. And this part of the circle that's only with tourism. And the part of the Venn diagram where it's outside. And then that's not, it's not really part of the Venn diagram that we write the total there, but it helps us, so get used to just writing your total at the right on the outside. Okay, you understand Venn diagram? The fact that we have a subject that you can either have tourism or geography or both makes this an inclusive event because of that cut there. Okay? So if we look at the formula we have there, we are saying the probability of A or B. Now understand that A or B, look here, this is A or B. This whole entire circle, everything there. The probability of A or B is going to be the probability of A. What's the probability of A was 10. Plus the probability of B, what's the probability of B? 10. So it's going to be 10 plus 10 is 20 minus the and. Okay, that gives me 20 minus 7 is 13. Do you agree with that? if I look at it in the Venn diagram, 3 plus 7 is 10 plus 3 is 30. Okay, so it checks out. That's where that formula comes from. And then you can just draw this Venn diagram. It's just a rough drawing, just so that you can see it has the cut in the middle. The cut in the middle is referred to the AND part. The OR part is everything inside of the circles. No matter where, it must just be inside. Or not? Can you see now? Better. Do you remember this word from grade 10? Inclusive events. Okay, done? Okay, the next one we'll have here is called mutually exclusive. Can you remember what mutually exclusive is? When it doesn't have the cut. Okay? So this one's equation will look like this. The probability of A or B, so that means everything in the circles, will be equal to the probability of A plus the probability of B. So then you don't subtract AND, because the probability of A and B is equal to 0. That means it doesn't exist. It's not there. And your Venn diagram looks like this. Number 3 is called exhaustive events. Now, just while we're looking at this word event, that is like the subject, making the choice of subject A and subject B, the choice of tourism and the choice of geography. Can anyone remember what it means when the events are exhaustive? Yes, that's correct. When all of them are in the circle. Okay, so we're going to say the probability of A or B is equal to 1. And you must remember, in probability, 1 is the same as 100%. And is the same as 1 over 1. That means all of them. Everyone. Now, while you're writing, I just want to take a step back to mutually exclusive, the previous one. Right? We didn't use a subject there for that one. Okay, mutually exclusive. This is something like if we refer to math and math literacy. Okay, there cannot be the cut in between. You can't have mathematics and math literacy. Okay? So if I take the grade 11D class, there will be a number of learners that has mathematics, and there will be a separate number of learners that will have math literacy. Now, if there was someone in the grade 11 group that for some or other medical reason or whatever are excluded from mathematics, that can happen, eh? There isn't someone that qualifies for that, alright? So don't get ideas. You can qualify so that you don't have to take mathematics. Then you will have a 6-subject matric, right? If there was someone like that, that person would be on the outside. But there's no one that can have both subjects. All right, now back to exhaustive events. Probability of A or B is equal to 1. Now I drew 2 Venn diagrams so that you don't think this is just for inclusive or just for mutually exclusive events. This can be for either one of the two. It just means there's no one outside. Everyone has taken the one subject or the other subject or both, and everyone had either taken the one or taken the other subject. Number 4, the last one. Are you still busy with the Venns? Okay, I'll give you a second. Is there someone that can remember what complementary events are? Complementary is going to be this one. Okay? It is when it's mutually exclusive, no cut, and it's exhaustive. Okay? So all of the learners are inside of the one circle. The one circle doesn't cut the other circle, and all of the other learners are in the other circle. So the maths and math literacy subject choice would be a complementary subject choice. Okay, and the formula that we use here is we can just say that the probability of A plus the probability of not A is equal to 1. Now let me explain this to you because it sounds very difficult. Okay. If I take the grade 11 D class and I say the probability of me choosing without cheating, okay, I'm going to choose a learner in the grade 11D class that has maths, mathematics, pure math, and the probability of choosing someone that do not have mathematics, in other words, they would have math lit, is 100%. Do you agree with me? Because if I choose someone in the grade 11 class, 11D class, they will either have mathematics, probability of A, or they will not have mathematics. Probability of not A. Okay, so it sounds very difficult, but it's actually very easy. Now I just want you to write down the second way as well. It's just a different notation. Just instead of writing not, it's not really a 1, but there's no other way to draw it. It's just a line. Okay, so it's not to the power of 1. That means not A. So these two things mean exactly the same thing. Are you done? Okay, then we can write example 1 and you can draw these two Venn diagrams. We are actually just going to work with Venn diagram number 1, the inclusive one, because we need to get used to the difference between or and and. Example 1. Now we're going to write down probabilities now. So I just want you to write down this formula. A probability is always a fraction, okay? We are going to write it as the number of positive outcomes, that will be our numerator, and the number of possible outcomes will be our denominator. So I know you all know this for a long time, but I'm just going to explain it so that everyone is clear. If I say I am going to close my eyes and choose a learner at random out of this class, what's the probability that I will choose a girl? Okay, so we're going to look at the number of positive outcomes. If it's positive, that means it's the one I'm referring to. So I'm referring to the girls. How many possible girls can I choose from? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 girls in this class. What is the total number of possible outcomes? That means the total number of learners that we have in this class. And we saw now it was 16. Alright, so the probability of choosing a girl at random would be 9 over 16. And then you can always simplify it if it's possible. Okay, but 9 and 16 cannot, there's no common factor for 9 and 16. But if there was, then you can simplify. Okay, Lesedi, we are going to start with you. So we are referring to the left-hand Venn diagram. So you must all listen because yours is coming up and these ones are getting more difficult the longer we go on. Okay. So first things first, Lesedi, this has to be a fraction, what I'm going to write here. What is the probability? These are not the number of learners. This is learner number 1, learner number 2, learner number 4, number 6, number 3, and number 5. You get that? Okay. But when I write a probability, I want how many over how many. All right. What is the probability of me choosing a number here that is A? In other words, when I say the probability of A, I'm referring to a number that is in A's circle. Which are you saying there are 2, or are you referring to number 2? I want to know how many are in A's circle. How many are in A's circle? Let's say 3. Okay, do you all agree with me? Is it not just that number? Because that's not a circle, ne? That is a circle. So there's 1, 2, 3 positive outcomes. Okay? So, for instance, let's say this is geography and tourism. I'm asking, who gives geography? Juffrou Kotse, ne? I want to send someone to Juffrou Kotse, but it must be someone that knows her, that has class with her. How many learners has got class with Juffrou Kotse? 1, 2, 3. So even though these 2 also have class at Juffrou Forshia, that's not what I'm referring to. I'm referring to learners that know Juffrou Kotse. So it will be 3. But I have to write a fraction, Lesedi. What is the total number of outcomes that I can have? How many learners are there in total? Three over 6. There are 6 learners in this class. 3 over 6. Come in. This can be simplified to what, Lesedi? 1 over 3. All right. The next one. Thank you. The next one I want to know is the probability of B. Junior, I want to send someone to Juffrou Forshia's class, but it must be someone that knows her, that has class with her. So I want the tourism kids. What's the probability of me choosing a tourism learner? 4. Is 4 a fraction? What am I asking? What is the probability? Who can tell Junior what he's doing wrong? Ona? 4. But what's he doing wrong? If you give a probability, it has to be a fraction. So 4 is not a fraction. So that's what I'm saying. 4 over 6. So listen to the question. 4 over 6, and that can be simplified to what, Junior? Yo, come on, this is grade 4. What? 3 over 2. Yo, guys. Isabella is doing this in grade 4 for real. Nee man, we can't be wasting time with equivalent fractions. Tepu, listen to what I'm saying. I want the probability. No, I don't want the probability. I want the number of learners. Okay? You hear what I'm asking? I want the number of learners that is not A. So A was tourism. No, the A was geography. I want to Skinner about Juffrou Kotse, right? So I want to Skinner to a kid that doesn't have class with her. So I don't care what you have, but you must not have A. You must not have geography. How many learners do not have geography? 3. Do you all agree with that? 1, 2, 3. 3. So what is the probability of choosing someone that I can Skinner with? 3/6. Which can be simplified to a half. Do you get the idea? I don't really want to Skinner about Juffrou Kotse, okay? Don't start a story into school. Or now I want to Skinner about Juffrou Forsier. Okay? What is the probability of me choosing someone at random that does not have class with Juffrou Forsier? 2/6, which can be simplified to 1/3. It's only learner number 1 and 2 that I can talk to about Juffrou Forsier, né? Okay, Courtney. Do you see this one looks a bit different? Do you know what's different in this thing than the other ones? There's actually 2 things that looks a bit different there. But the main thing, they're not asking for a probability. Okay, so that's the difference in the questions that I asked. What is the number of learners and what's the probability of doing it? Okay, but this question actually asks, who is A or B? Who is A or B? Who are the learners that has geography or tourism? Okay, so I don't care, when we refer to or, we don't care whether you have just the one, just the other one, or both. I don't know where north and east and south and west is. So I need someone that has geography or tourism to come and help me. If you have geography and tourism, that's fine as well. Who has geography or tourism? Very good. So we're going to write it like this with a curly bracket. 2, 3, 4, 5, and 6. And then we close the curly bracket. Now I want you to add one here that I didn't do with the Afrikaans class, I should have. Okay. Zora, I need someone that has intense knowledge of north, east, south, and west. So they should have geography and tourism. Easy. Okay, you see the difference between or and an? Right, Kutlanu. Now, can you tell me, this is now very easy. You see, this one is different than that one. This one, they just ask who has A or B. Now I want to know what's the probability of choosing someone that has A or B. Who are the 3 that you are identifying? Either A or B. So I'm looking for anyone that can tell me where north, east, south, and west is. That was what Courtney's question is. Do you remember that? She said the ones that have geography or tourism. is number 2, number 3, number 4, number 5, and number 6. Okay? So I'm asking, what's the probability of choosing one of them? 5 over 6. Okay? Listen to me, Kutlano, when you refer to 3, that you refer to 2, 3, and 5. If you're in between, you still have geography or tourism. Okay? It's fine. It must just be in one of the circles. Remember, or is everything in the circles. And is the cut in between. Okay. What about that poor person outside? Everything in the circles. I want to know what's the probability of choosing someone that has geography or tourism. This learner just doesn't have either of them. You understand? Who didn't want geography or tourism in this class? So why can't I choose them? You understand what I mean, Khalaledu? Okay. Next one. Sia. Probability of A and B. So what's the chance of me choosing someone in this class that has geography and tourism? 2 over 6, which can be simplified to 1 over 3. Hope, hope, hope. Here comes the trouble. Okay, I'm going to help you. When we have and, it must be both. Okay, so A and B has to be geography and tourism. Doesn't matter if this is A or whatever, but and must be true for both. Or can be true for either one or for both or whatever. It must just be either one of them. At least. That's actually the right word. At least the one or the other. If it's more than the one or the other, that's fine as well. But at least that. Okay. So look at what this question asks. It wants the probability of A and not B. Okay? A and not B. So it must be true for both. Now, if I can give you advice for this, take them one at a time. Okay? So we're going to first look at A. Can you tell me which numbers qualifies to be A? Okay? So who of these learners have got geography, tourism, geography only? A. 2, 4, and 6. Do you understand that? So when I'm asking for the probability of A, I'm asking who's in A's circle. When I'm asking Hope, because we're done with A now, who is not B? That means you're not allowed to be in B's circle. Who's not in B's circle? 2 and 1. Do you all understand that? I didn't take it as a whole. I took probability of A and then I wrote down the values for the probability of not B. Now when the question is and, you go and look which one is there for both of them. Because it has to be for both of them. So Hope, how many numbers occurs in both of them? 1, it's the number 2, ne? So what's the probability of choosing someone that is A and not B? 1 over 6. Do you see that if you're going to take this as a whole, it's going to confuse you when you refer to A and not B? And must be true for both. Nyakalu, what is the probability of not A and B? So you see they're asking and again. So therefore it must be true for both of the events. Now the first event is not A. Who is not in A circle? Only 3 and 5. 1, 3 and 5. Everyone that's not in A circle. Nyakalu, the next one is and B. Who is in B's circle? Is that B's circle, that small part there? 3, 4, 5 and 6. Okay, do you agree with that? Because they're asking for and, it must be here and there. Which numbers are here and there? It's 3 and 5. So what's the probability of getting one of them? 2 over 6. Always written as a fraction, which can be simplified to 1 over 3. Sibabatsu, are you ready? Now it's almost the same, but we're not asking for and. We are asking for or. So remember, when you read or, I want you to see at least. Okay. So we're looking for the probability of A or not B. It must just be one of the two. Okay. It can be both, but it must at least just be one of them. So we're going to do it in the same way. Probability of A. Who is in A's circle? Who is not in B's circle? Okay, now when we take this probability when it's or, if it was and, we would have chosen 2 and just 2, because it's there both. But when we choose or, we must just have everything there. But 2 is repeating there, so we can't have 2 twice. So it's going to be 1, 2, 4 and 6. Does that make sense? So what's the probability of getting one of them? 4 over 6, which can be simplified to 2 over 3. Do you all understand that? Rory Sang, probability not A or B. So at least one of them. We take it one at a time. Who is not A? 1, 3 and 5. They are not in A circle. Or B. Who is in B circle? Okay. If they asked for and, we would have chosen 3 and 5 because they repeat. But this is or, so it must at least just be one of them. So it's going to be 1, 3, 5. That's 3. Ne? Plus 4. Not them again because I already have them. And 6. Can you see that? So it's 1, 2, 3, 4, 5 numbers. That is either not A or B. So it's going to be 5 over 6. And if you think about this, it actually makes sense. How many numbers do you see that's not A, not A or B? This is B, this is B, this is B, this is B. Right? This is not A. There's only one that is just A. You see that? And that's the inverse of 5 over 6. But you don't have to think about it logically. I said to the Afrikaans class as well, you do it like this, and then you're done. Don't go and read it again, because this English is not the same as the English we speak. Okay. Right, or two. I want the probability. You must now know what A or B is, and you know where A and B is. No? What is the probability of choosing someone that is not A or B? Look at the way it's written. Not, and then in brackets, A or B. So it's not like this one where I say not A or B. You must first know where A or B is. When you know where A or B is, I want the ones that's not it. 1/6. There's only that number 1 on the outside. That's not A or B. Well done. Hallelujah. Sorry, it needs a B there. I see I didn't write it. I want the probability of not in brackets A and B. So you see the difference between that question and that question, eh? I want not A and B. So you first have to know what A and B is. What's the probability of choosing someone that is not A and B? 4/6. Because the ones that's A and B is 4 and 6, ne? Those are the only ones. Let me finish. And this gives me 2/3. I'm gonna steal 1 minute of your time. Okay. Just one more question. The probability of B plus the probability of not B. Okay? What's the probability of B? So how many of them are in B circle? How many are in B circle? 4/6 plus the probability of not B. How many is not in B circle? Plus 2/6. So I'm just doing this one so you can see these are two different probabilities. And you would just add them, it would give you 6/6, and that's 1. Now last thing. Looking at the Venn diagram of C and D, we didn't really answer questions on it. Because the probability of C, it's easy, ne? It's 2/5. The probability of D is 3/5. The probability of C or D is 5/5 because they're all in the circles. The probability of C and D, 0 because there's no cut in between. Okay, so we didn't really answer any of the questions on this one. I'm going to give you homework that's exactly like this. You're going to have your own 2 Venn diagrams and then you're going to answer some of them. So in your textbook, I will also take a picture for you and put it on the group if you want me to. It is exercise 4. It's on page 261. So you can just use a pencil to identify the ones that you have to do. I've circled the ones, but I will send it on the group as well. So you've got your 2 Venn diagrams, and then you answer these ones. It's just practice for this. If you can read and understand probability, then drawing the Venn diagrams and doing everything with the tree diagrams is going to be much easier. Okay.